那么，首先呢，我们有请这个卡瓦诺，阿根廷国家研究委员会研究员，布宜诺斯艾利斯大学建筑学院教授。好，我们现在请出卡瓦诺教授。
Sets of color samples have been always used as instruments in various fields of color research. For instance, in studies on color semantics, psychology, marketing, color emotions, environmental color design, and many others. The problem is that usually these color sets are just fitted to a particular purpose, and the same instrument is not used for different investigations. This makes, of course, the comparison of results impossible.
A project carried out by a group of colleagues was the starting point for my interest in this subject. In 2022, Georgina Ortiz, Mabel Lopez, Citlali Ortiz, and Elisa Cordero started a survey to study the relationship between color and fears in Mexico, Argentina, and Chile. They designed this instrument with 12 color samples, with the collaboration of Alfonso Claros from Bolivia. The color categories adopted were white, green, orange, brown, gray, blue, purple, cyan, magenta, yellow, black, and red. The criterion was to choose a set that roughly corresponds to 12 basic color categories, somewhat in the way of Berlin and Kay's 11 basic color terms. The selection was made with the criteria of visual differentiation, trying to choose colors that are representative of their class. But the problem is that these samples are not referenced to a color atlas or a standard notation. So, if these color samples need to be reproduced for another research, this inaccuracy would affect the comparability of the results. Here, our questions arose. Was it necessary to develop a new instrument? Or perhaps a standard 12 colors instrument used in previous investigations should have been applied instead? Has such an instrument existed along the history of color psychology research since the beginning of the 28th century? Has anyone intended to compare the multiplicity of research on color psychology, semantics, preferences, etc., based on the same reproducible set of samples? In the research that was our point of departure, 12 color samples were required. So, how to solve the questions if a different number of samples is needed? Let's make a review of some antecedents. I will analyze some proposals by Bradley, Guilford, Hogg, Civic, Berlin and Kay, Kelly and Judd, and Kaboyashi. In 1995, Milton Bradley published a chart with 90 color samples. From each of the 18 hues of his color cycle, there are 5 colors. One is the vivid or most saturated color. 2 are tints, colors mixed towards white. And 2 are shades, mixed towards black. In 1934, Bradley's set was used by Joy Guilford in order to study the affective value of color. Guilford employed a set of 40 colors extracted from Bradley's chart. Here we see a monochrome triangle for each of the 18 hues. marked in black are the samples chosen by Guilford. In gray, the remaining Bradley colors. One problem with this set is that it does not include white, gray, and black. It also does not include grayish tones, that is to say, there are no colors from the middle or the inside space of each triangle. The fact that Guilford used Bradley's colors would make it difficult to reproduce his samples with accuracy today, since only old editions of Bradley's book exist, and their swatches are faded by the action of time. However, Guilford made visual matches of Bradley's samples to the Munsell Book of Color. The table here provides the Munsell notation of the 4-tier samples. Thanks to this, today we have a reference of what the colors were, because the Munsell Atlas continues to be published. To define the response to colors using the method of semantic differentials, James Hogg in 1969 selected 30 colors from the Munsell Atlas. Hogg only used the 5 principal hues: red, yellow, green, blue, and purple. Intermediate hues are not represented in his repertoire. For example, there is no orange. The selected colors have the values and chromas indicated here with black circles. Some lack of regularity is noticed in the intervals among colors. On the other hand, we find no white, grays, and black selected. Another problem regarding the instruments used both by Guilford and Hogg is that they are different from each other and have not been replicated in other investigations. So they remained as isolated cases in themselves. In order to carry out studies of color associations with semantic differential scales, Taft and Civic used in the 70s a set of 27 color samples taken from the natural color system. These are the locations in the color cycle and in a triangle with the gray scales showing chromaticness and blackness. We see that there are colors representative of different hues, chromaticness, and blackness, but the space in between them is not uniform or regular. In addition, there are some areas of the color space that are not represented by a sample. On the other hand, the fate of this set of color was not different from the previous ones. It was used by some other authors who replicated the research in different countries, but nothing more. There is a case where the use of a set of standard colors was generalized. Starting with Berlin and Kay's book of 1969, all the research on linguistic and cognitive color categorization used this set of 330 colors from the Munsell Atlas. Thanks to this, it was possible to formulate, for example, a worldwide survey of color names, which has been carried out for several decades throughout the world. This is a good example to follow, but there is a limitation. The set has the achromatic colors here, the 40 saturated colors of the Munsell circle, those colors that blend towards white, the pastel colors or tints, and towards black, the shades. But it does not have grayish tones. There are no colors from the inner space of the Munsell solid except for the achromatic axis. Only the colors from the outer surface are represented. It is as if from a peach, for instance, we keep the skin and the pit and we discard the pulp. For the research on color semantics, in order to develop his color image scale, Shigenobu Kobayashi adopted the Munsell system and the Inter-Society Color Council and the National Bureau of Standards method for designating colors by Kelly and Schad. Each of the Munsell hue triangles is divided into 12 zones, apart from the scale of grays. These 12 zones correspond to small sets of colors of the same hue, sharing a similar characteristic, which can be expressed verbally with some precision. So each hue, for example, red, yellow, green, blue, purple, is divided into 12 categories: vivid, bright, strong, deep, pale, light, dull, dark, very pale, light grayish, grayish, and dark grayish. In addition to this, we find the scale of grays here on the left, with white, light gray, medium gray, dark gray, and black. This neutral scale is common to all hue triangles. The 12 zones or categories can be grouped in turn into 4 more general chromatic categories in each hue triangle. The vivid or pure colors at the right vertex of the triangle, the tints, that is to say, pale colors mixed towards white, the tones, which are the grayish colors here, and finally the shades, the dark colors that are mixed towards black. Apart from them, as we have said, there is a category of neutral colors, the gray scales, that is to say, the colors with zero chroma, which work as a common axis for all hues. Kobayashi's proposal is perfect from every point of view, both methodologically and in practice. It meets the requirements that we consider essential to build an instrument of this type. That is, using a standardized color order system, selecting areas that cover the entire color space in its 3 dimensions, following the criteria of homogeneity and equidistance, that is to say, regularity in the intervals among samples. Kobayashi selects 20 hues for the zone of the vivid colors and 10 hues for each of the other 11 zones, plus 10 neutral colors. That is to say, a total number of 140 colors. Well, our proposal is to develop a series of standard sets of reference colors that can be used as instrument in all kinds of color research in various fields. The criteria are to consider the entire set of color samples that are included in a color order system, for example, the Munsell system or the natural color system, which contain around 1,500 samples, and from this to divide the atlas homogeneously, maintaining equidistance between the colors. Since different investigations may require a greater or lesser number of reference color samples, these sets can be made larger or smaller. This is accomplished by dividing the color space of the reference systems in different ways, but keeping in mind that all the zones are represented by some sample. This is a schematic example of a small set, modeled on a generic system that divides the color wheel into 6 hues. We have then 6 saturated colors and 3 achromatic ones. From each hue, with its pure or vivid color, and towards the achromatic axis, we have 3 intermediate colors: a tint, a tone, and a shade. This gives 27 colors in total, and it is just a general example where it will be still necessary to specify the standard notation for each color. Let's take the Munsell book of color to exemplify our criteria and present some of the mentioned color sets. The Munsell color wheel is divided into 5 principal hues, designated by the initials of the color names: red, yellow, green, blue, and purple. Then there are 5 other intermediate hues designated by combining those initials, that is, yellow-red, green-yellow, blue-green, purple-blue, and red-purple. And finally, each of the 10 hues is subdivided into 4, in order to reach a total amount of 40 hues. Here we can see the general criteria for selecting samples from a certain Munsell hue triangle. We take 5 samples from the neutral scale with values 1, 3, 5, 7, and 9. And we take chromatic samples of the same values with chromas 1, 4, 8, and 12 when it is available. If we make the same selection in 10 hue triangles, the resulting set amounts to 98 samples. This is the process by which, from the large set, we add more samples or skip some samples in order to obtain the other sets. So, the extended set incorporates more colors by selecting all the 9 samples from the neutral scale, by adding 10 intermediate hues, amounting to 20 hues in total, and by adding some particular samples in the hue triangles. For instance, the tint that is closer to white with value 8, and the shade closer to black with value 2, this one, when they are available. The medium set is just a subset of the large one. In it, all the samples of chroma 1 are excluded. Finally, the small set is a subset of the medium one. It takes only 3 samples from the neutral scale: white, mid-gray, and black, and only 5 hue triangles, corresponding to the 5 principal Munsell hues. In addition, we exclude the intermediate chroma between chroma 4 and the most vivid color of each hue, so that for each hue we have just one sample belonging to each category. That is to say, one vivid color, one tint, one tone, and one shade, as in the general case shown previously, but now with 5 hues instead of 6. Taking into account that the number of Munsell principal hues is 5, in all sets the number of hues are multiple of 5, with exception of the basic set, as we will see. So the distribution in terms of the number of color samples for each category will be the basic set with 11 or 12 colors, based on Berlin and Case categories. The small set with 23 colors, the medium set with 58 colors, the large set with 98 colors, and finally the extended set with 195 colors, which is similar to Kobayashi's proposal. For the sake of brevity, I am going to skip here the development of the large and extended sets. Let's then look at the medium set of 58 colors and the small set of 23 colors. And finally, let's consider how a basic set of 11 or 12 color samples related to the basic color terms can be extracted. The medium set of 58 colors uses 10 of the 40 hues available in the Munsell Atlas. From the scale of 9 neutral colors, 5 samples are selected: black, 3 grays, and white, at values 1, 3, 5, 7, and 9. Note that one of the 3 gray colors is precisely the middle gray, a very important color for Munsell. Then, colors of chroma 4, 8, and 12 are selected at the same value levels. Taking into account that chroma 12, this one, is not always available in all hue triangles, when this happens, the sample of maximum chroma is chosen, whether it is chroma 10 or chroma 8. Here we see the 58 colors in the 10 monochromatic triangles, with their Munsell notations below. And here the same colors are arranged in the hue circles, separated by value level. All the categories of the color space or color solid are represented. The set of achromatic colors with 5 categories: white, light gray, middle gray, dark gray, and black, and the set of chromatic colors with 4 categories: vivid colors, tints, tones, and shades. The number of samples arranged by category are 10 vivid colors from the 10 hues, 17 samples of tints, 10 samples of tones, 16 samples of shades, and the neutral or achromatic colors with 5 samples. In order to arrive to the small set of 23 color samples, the following procedure is applied. Instead of selecting the 10 hue triangles as in the medium set, we take only the 5 principal Munsell hues: red, yellow, green, blue, and purple, as we can see here in the color wheels. Only one vivid color, one tint, one tone, and one shade are taken in each of the 5 hue triangles. Instead of the 5 neutral colors, we skip value 3 and value 7, so that only 3 samples remain on the achromatic scale: value 1, 5, and 9. That is to say, black, middle gray, and white. The chroma steps are reduced to 2. Chroma 4, which is almost central in all hue triangles, and the most chromatic sample that is available. By that means, the medium set is reduced to the 23 colors of the small set. Here again they are presented in the hue circles separated by value level. In the small set we find 5 vivid colors, 1 for each hue, 1 tint, 1 tone, and 1 shade in each hue triangle, and 3 achromatic colors. Even in this reduced version, the 3 categories of neutral colors, white, gray, black, and the 4 categories of chromatic colors, vivid colors, tints, tones, and shades, are preserved. That is to say, the entire space of the Munsell system is represented, at least with 1 sample in each category. How can we extract a basic set of 12 colors from the Munsell system? First, we take the 3 achromatic colors, white, gray, and black, and the vivid colors of the 5 main Munsell hues, red, yellow, green, blue, and purple. So, we have 8 colors that are representative of the basic names. Among the 11 basic names, we must also include orange, brown, and pink. Then it is necessary to select the yellow-red hue with its vivid color, that is orange at the highest chroma. From the same hue, one of the shaded colors will be the brown that we need. Finally, from the red hue, one of the tinted colors will be pink, and this will complete the series of 11 colors of the basic names. However, there are cultures and languages where 12 basic color names are used instead of 11. This is the case, for example, when celeste, that is the color of sky, a light or pastel version of blue, appears in addition to blue, and this happens in the Spanish language that is spoken in Argentina and Uruguay, and also in the Russian language, which shows a similar situation of having 2 basic terms for 2 different blue categories. This sky blue sample is simple a pastel color within the blue triangle. In conclusion, I have presented just a few examples. There are several more developed with different partitions and amounts of samples in relation to the Munsell system and to the natural color system. Similar procedures can be followed in the case of other color spaces. The criteria will be the same, using a standardized color order system with its notation in order to specify the samples, selecting zones or categories that cover the entire color space in its 3 dimensions, keeping homogeneity and equidistance to the extent allowed by the color system that is used, with equivalent color difference between different adjacent samples, and making each smaller set to be a subset of the larger ones, whenever this is possible. This proposal aims to cover a need that, despite of being quite evident, does not seem to have been satisfactorily solved so far. Thank you.
这是一个非常专业的研究哈。